Hello everyone, welcome back to the heat exchanger simulations. As we discussed earlier, the heat exchanger simulation help us to determine outlet temperatures, area of heat exchangers, heat transfer coefficient. Today we are going to see about the outlet temperatures. So here we are go the process parameter that we are going to use is hot stream of toluene at 100 degrees centigrade and a flow rate of 50 kg per hour at 1 bar. Similarly, cold stream consists of water at 25 degrees C and flow rate of 60 kg per hour at 1 bar. Area of heat exchanger given is 1 meter square. So the objective of this simulation is to find the outlet temperature of the hot stream, how much the toluene will be get cooled if the water is heated to 30 degrees C by a heat exchanger of area 1 meter square. So let's go to the DWSIM and do simulate and figure it out. So open the DWSIM, click on new steady state simulations. So the new simulation configuration wizard will open. Click on next. Choose a component that is toluene and water. You will see those are added here. Click on next. Select the SRK model because we are using hydrocarbons. Then in the system of units, select C5 because C5 the units of the properties are the units that we are selected in our examples. Then click on next, and then finish. Now from the heat exchanger, drop the heat exchanger to the flow sheet. Name the two inlet streams at one of the stream as toluene inlet. This will be the toluene inlet. Temperature is 100 degrees centigrade. Pressure is 1 bar. Flow rate is 50 kg per hour. And the compound amount. Toluene will be only toluene will be here. Water will be 0. Click on normalize. We want water to be 0. Toluene is only there. Normalize and then click on accept the change. So here we set up the toluene streams with the desired property. Now click on the second stream, second inlet stream of heat exchanger. Make it as water inlet at 25 degrees C, 1 bar and 60 kg per hour. To compound amount, here we want toluene equal to 0, make it normalize, accept the change. So you have a water stream at 60 degree, 1 bar and 60 kg per hour, 1 bar and 25 degrees centigrade. Now click on heat exchangers. Here you can see outlet stream of inlet stream 1 is third. So rename third as the toluene outlet. Similarly, the fourth one as the water outlet. And here the heat exchanger 1. Now click once again on the heat exchanger 1. In the just check inlet stream 2 and outer stream 2 should have the same names. The same components should come in and go out because the pipes are connected in the heat exchanger. So whatever coming in should go out. So here flow we want counter current and we want to calculate the outlet temperature of the hot fluid. Here it wants us to specify the cold fluid outlet temperature. We know that is 30 degrees centigrade. As we know there is no pressure drop, so the pressure drop will be 0. Area of heat exchanger made it as 1 meter square. By default it is 1 meter square only. Now heat loss as ideal, we are considering the ideal situation. There is no heat loss. Ignore the LMTD error and then now click again on solve. Now once again click on solve. It is solved. Now what I will do, I will enter the property tables. To check the temperatures. So click on here. I just want to check the toluene outlet temperature. You can see the outlet temperature of toluene. I want to see the water outlet temperature. You can see the outlet temperature of water. Let's say include for the toluene inlet temperature and mass flow both. So similarly for water, temperature and mass flow, you will get Now here I just want the heat exchanger property, the global heat transfer coefficient, heat exchanger area, and heat load. These three crucial things are there. Then you can see the heat exchanger area we specify 1 meter per square. Global heat transfer coefficient 6.19. Heat load is 0.401 kilowatt. So from this, what we conclude that if we use a heat exchanger of 1 meter square area, having a global heat transfer coefficient as 6.19 watt meter square per Kelvin, we will and we want to cool the toluene from 100 degrees C to 84.82. The water will be hotter to 30 degrees C or vice versa. If we water is heated to 30 degrees centigrade, the toluene will be cooled down to 84.8 degrees centigrade with a heat exchanger of 1 meter square area. So this is the one of the another aspect of the heat exchanger.